Have you heard about robotic butlers that work as servers in restaurants, prepare drinks for you, and even act as assistant chefs? Well, robots are now helping grow the very crops that you eat and cook. You heard me right. Welcome to Mechatricon, your ultimate destination for all things robotics and engineering. In today's video, we'll embark on an immersive journey into the fascinating world of robotic technology, exploring how this innovative technology is revolutionizing sustainable food production. Get ready to dive deep into the technology, science, and physics behind this remarkable system. Let's get started without any further ado. Robotic agriculture is a cutting edge approach that combines advanced robotics, artificial intelligence, and data analytics to optimize crop production, minimize waste, and ensure sustainable practices. Let's break down the key components and processes involved, unraveling the intricate workings of this remarkable system. At the heart of robotic agriculture lies a sophisticated sensor network strategically placed throughout the farm. These sensors continuously monitor a wide range of environmental factors such as soil moisture, temperature, humidity, light intensity, and even plant health indicators like nutrient levels and disease. This comprehensive data collection allows the system to make informed decisions regarding crop management. The sensor network acts as the eyes and ears of the system, providing real-time data on the farm's conditions. This data is then fed to a central control system, which kind of acts as the brain of the operation. The central control system now receives and analyzes the data from the sensor network, utilizing advanced algorithms and machine learning techniques. By processing this vast amount of information, the system can now make intelligent decisions regarding irrigation schedules, fertilization, pest control measures, and even harvesting operations. The integration of AI and data analytics enables the system to optimize resource utilization, maximize efficiency, and ensure sustainable farming practices. Now, let's explore some of the groundbreaking technologies that are employed in robotic agriculture. One such technology is the use of autonomous drones. These drones are equipped with high resolution cameras and multispectral sensors that enable them to capture detailed images and collect data on crop health. Through computer vision and machine learning algorithms, the drones can now analyze the captured data to detect patterns, identify anomalies, and assess the crop health. The real-time information empowers farmers to make data-driven decisions regarding irrigation, fertilization, and pest control. The drone's ability to provide precise and timely information is a game changer in optimizing crop production. To achieve precise targeting in treatments, the drones leverage the science behind it. Through understanding the principles of optics and light deflection, the drones can analyze spectral signatures that are emitted by the crops. Each crop has its own unique spectral response, indicating its health and specific needs. The drones utilize this information to apply treatments not only to the affected areas, which minimizes chemical usage and reduces overall environment impact, but this targeted approach is made possible by the application of physics principles, optimizing both crop health and resource efficiency. In addition to this drone technology, precision irrigation plays a crucial role in robotic agriculture. Water, being a precious resource, must be delivered precisely where it's needed to maximize efficiency and minimize waste. Precision irrigation systems utilize the science of fluid dynamics to achieve optimal water distribution. Through carefully controlling water pressure, flow rates, and emitter design, these systems ensure that water reaches the plant's root zone directly, reducing evaporation and minimizing runoff. The application of physics in irrigation helps us in conserving water resources, which makes farming more sustainable and more efficient. Within the realm of robotic agriculture, design and control of robotic arms also play a pivotal role. Robotic arms are engineered to mimic human like dexterity whilst being robust enough to handle the demands of agricultural tasks. The physics of force sensing and control is also crucial in understanding that these robotic arms can handle crops delicately. Force sensors that are integrated into the robotic arms can provide feedback on the amount of force that is being applied. This information is then used in control algorithms to regulate the gripping force and prevent damage to the crops. The motion planning algorithms also optimize the trajectory of the robotic arm, considering factors such as speed, acceleration, and deceleration to form precise and efficient movements. By combining advanced robotics, artificial intelligence, physics, robotic agriculture systems enable farmers to achieve unparalleled precision, efficiency, and sustainability in food production. These systems have the potential to revolutionize the agricultural industry, addressing challenges such as resource scarcity, labor shortages, and environmental concerns. In conclusion, robotic agriculture merges technology, science, and physics to create a powerful system that optimizes crop production, minimizes waste, and ensures sustainable practices. Through the use of sensor networks, central control systems, autonomous drones, precision irrigation, and robotic arms, farmers can leverage the benefits of enhanced robotics to enhance productivity, reduce environmental impact, and meet the ever growing demands for food sustainably.